Those in our audience who are completely in the dark or unaware of what it actually means, how would you best define quantum computing?
I can take a lead on that. So I think one of the things to look at is that at the moment, if we're looking at classical computing, then we're using bits. Bits, they come in numbers as in 0 and a 1. Whereas, and we're using classical systems to resolve these two issues, to process information, to process data. Now, with quantum computing, we're using qubits, quantum bits essentially, and these qubits, they come with different properties. And what we read in the press and what we know are the properties of superposition. So probabilistically, a qubit can assume the position of a 0 and the 1 at the same time until it's being measured. Qubits can also be correlated to each other. So what happens to one set of qubits at one end then can have an impact on another set of qubits at another end. And the combination of superposition and entanglement essentially enable quantum computers to perform computations all simultaneously, whereas compared to a regular computer, the computer would perform these calculations in a sequential manner and hence would take more time to perform these calculations. Another thing to consider is maybe quantum computers are meant to solve very complex problems. So they're not meant to solve our Excel problem a little bit faster, but we're looking at very complex problems. So if we look at traffic jam problems, let's say somewhere in London, we have so many variables that need to be included in there. We want to resolve that. We want to get people from A to B in the fastest possible time. And so these kind of complex problems, they are then being solved hopefully in the future by quantum computers.
I just want to add to that and say, I think the simplest explanation that I usually use is imagine walking into a library and you need to find a problem. You need to find a solution to a problem that lies in that library. You have to open and read every single book to get to the answer to the problem. Imagine a magical library where you walk in, all the books are open, and you get the answer straight away. And that's the difference. Right. So what does that mean in terms of real world implications? It means that all the problems that we're seeing that we are told will take years to solve. For example, a couple of years ago, there was a problem given to the world's fastest supercomputer, and it said it would take it 45 years to solve. Now, a 90 qubit Google a quantum computer solved that in about 30 seconds. So that's a difference.
That's the power of quantum